So taste, or gustation, is a really simple sensory system, actually. When we say taste, colloquially, we generally mean flavor. Taste is really very simple. Here's a taste bud, and what happens is the mouth, and there's molecules and ions in the foods that we eat, and they bind to cells on these elongated taste receptors. And when enough binds, the cells get excited and they send a single signal to the brain that the brain then interprets as a taste. And so this is evidence then that the brain is taking this afferent information about the sensory world and doing something with it that will help us perceive what it is. So for flavor, the mouth is the receptive field. But there's a problem, and the problem comes in by the fact that flavor is what we call a proximal sense. You have to be in contact with it to sense it. And that means that the receptive field is on the spot where the food, the flavor, is touching the cells, the mouth. And so oral somatosensory receptors are all over the mouth. However, taste, in fact, is only in discrete spots on the tongue, so at the back, the side, and the tip. It's even worse for retronasal olfaction because this depends on volatiles escaping from the mouth when you're eating, and then they go up through the nasopharynx, and those volatiles come up, and they don't bind receptors in the mouth at all. Their receptors are up here in the nose. So taste evolved to detect the presence of nutrients and toxins. And when you're born knowing that you like sweet and dislike bitter. And that's good because you don't want to have to learn that sweet is energy and bitter is toxin. Having to learn that could be very perilous. So this is an innate affective response to a stimulus.